Now let's just see the next theorem, the theorem number 4, which says that if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. So basically we have to prove that the two lines are parallel. So let us suppose if I'm just starting with the figure of this one. So let us suppose if I'm taking the two lines over here as AB and CD, AB and CD, we have to prove that these are parallel to each other. So let us suppose if I'm just taking a transversal over here and I'm calling it as nothing but PQ. Let us suppose if I'm calling this angle as angle 1, I'm taking this as angle 2, I'm taking this as angle 3. So furthermore, I am just taking the given condition over here. The given is the two lines A, B and CD, they are not parallel because we have to prove that they are parallel. Two lines A, B and CD, and PQ being a transversal, and there is a condition that is given to us, that is angle 2 plus angle 3 is nothing but is equal to 180 degree, because in the question it is given to us that a pair of the interior angles on the same side of the transversal, they are forming a supplementary angle, means this is equal to 180 degree. Now we have to prove that the two lines are parallel to each other. So basically we have to prove that AB is parallel to CD. Now let's just start the proof. First of all, what can we say about the angles? So as you can see over here, we know that angle 2 plus angle 3 is equal to 180 degree. This is already given to us. Furthermore, we can say that angle 1 plus angle 2 is nothing but is equal to 180 degree. Why? So because they are forming a linear pair axiom. Through a linear pair axiom, we can say that their sum is nothing but 180 degree. Let us suppose if I'm calling it as 1, I'm calling it as 2. So from 1 and 2, what we can say? We can say that angle 2 plus angle 3 is equal to the angle 1 plus angle 2, because if both of these are equal to 180 degree, so it implies that they are equal to each other, and from this we can say that angle 2 and angle 2 get cancelled with each other, and we are getting at the end angle 3 is equal to the angle 1. So if the angle 1 is equal to the angle 3, so definitely they are forming corresponding angles. It implies that angle 1 is equal to angle 3 implies they are corresponding angles. They are forming corresponding angles. So corresponding angles are equal, it implies, and if the corresponding angles are equal to each other, it implies by the converse of the corresponding angles axiom that AB is parallel to CD by the converse of the corresponding angle axiom, angles axiom, that if we have a pair of corresponding angle equal in a pair of the lines and a transversal, then definitely the two lines are parallel to each other. So this is nothing but the proof of this particular theorem, that whenever we have a transversal intersecting two lines such that a pair of interior angles on the same side is supplementary, then the two lines are parallel to each other.